the answers here. This is a fairly long assignment, a lot of problems, and the way we do them is going to probably take a long explanation, but let's go over these real quick. Use the diagram at the right. Is each statement true? And you're supposed to explain why. You're supposed to explain why. If you know the definitions, this is not too hard. All right, we asked angle 2 and 5 are adjacent. 2 and 5, are those adjacent angles? No, they are not adjacent. Adjacent angles, these two angles have no common side. Adjacent angles have three things: a common vertex, a common side, no common interior points. So the sides of angle 5 are this ray and that ray. The sides of angle 2 are totally different rays, this ray and that ray. So no, those are not adjacent angles. Next, angle 1 and 4 are vertical angles. The answer would be yes. The sides are opposite rays of one another. Here's angle 1. Its sides are here and here. Angle 4 sides are here and here, which are opposite rays to the ones of angle 1. Number 3, angle 4 and 5 are complementary. 4 and 5 are complementary. No, they're not. They're supplementary. That's a linear pair of angles, and a linear pair of angles always add up to be 180. The measure of angle 4, which is from here to here, plus the measure of angle 5 from here to here, make this straight line, or straight angle, which would be 180, not 90. Complementary is 90, supplementary is 180. Now we could conclude up here if they said 3 and 4. 3 and 4 are complementary because they add up to be that right angle, 90 degrees. So, but they didn't say 3 and 4, they said 4 and 5. All right, the next problem, name an angle or angles in the diagram described by each of the following. So you give me a name. Angles that are complementary to BOC. Well, here's BOC, BOC. Complementary to BOC would mean that they add to BOC to make 90. Now, since this angle here was a right angle, then this angle right there would also be a right angle. That would be a box, because that's a linear pair of angles. AOC and COD make 180 degrees, linear pair. So this angle and this angle are complementary. So complementary to COB would be angle AO, or I wrote BOA, BOA. And then the other angle would be this angle, because it's congruent to this one because they're vertical angles. So the other angle is DOE. First, this one, because together they add it to be 90, that right angle. Then this one, because if it's congruent to this one, then it also has to be complementary to that one. Supplementary to DOB. DOB, supplementary, usually you can look on either side. Supplementary means together with this angle, they add up to be 180. So DOB and DOE make the straight angle BOA. So DOE is one of those angles that are supplementary to DOB. And then on the other side, BOA. See, this angle plus this angle make this straight angle. So BOA is the other angle that is supplementary to DOB. Next, number 6 says adjacent and supplementary to AOC. Well, AOC is this angle, AOC. Adjacent and supplementary would be COD, because together they make up that straight angle. Remember, that's a right angle, and if together they make up a straight angle, they're supplementary, then this would be a right angle as well. So we also know that COA is a right angle, so its supplement would have to be a right angle. 90 plus 90 equals 180. These next problems, we have that picture, and I put them all on a separate sheet of paper, so let me flip over there at the separate sheet of paper and let's look at those. So here's number 7. I redrew the picture to the best of my ability anyway. And we're going to find the measures of the angles. So I can put them on the picture. It makes it a little easier, but I'm going to have to erase because I have several angles. All right. First, number 7 says that AOB's measure, AOB has a measure of 4x minus 1. So this is 4x minus 1. BOC, next to it, this adjacent angle, has a measure of 2x plus 15. And then it says that AOC, and AOC is this whole angle here, that whole angle, has a measure of 8x plus 8. So our equation is going to be that these two smaller angles, this one plus this one, is equal to the larger angle. Okay? And so what it ends up being is, when I substitute in, the measure of AOB is 4x minus 1, the measure of BOC is 2x plus 15, and they're equal when added together to AOC, 8x plus 8. 4x and 2x is 6x, negative 1 and 15 is 14. Subtract 14, oh no, subtract 6x, I did that first. 6x from 8x is 2x, then subtract 8, 8 from 14 is 6, divide by 2, x is 3. And to find the measure of each of the angles, that's what they asked me to do. They said solve for x, and then find the angles. So x was the answer, then I had to solve the angles. Remember, AOB was 4 times x minus 1, or 4 times 3, which is 12 minus 1, or 11. BOC was 2 times x, or 2 times 3 plus 15, which is 6 plus 15, 21. And then AOC, of course, we know it's going to be 32 because it's the sum of these two. But to make sure that we did it right, it was 8 times x, or 8 times 3 plus 3. 8 threes is 24, plus 8 is 32. So everything worked. There's the measures of the angles, and there's the value of x. And it works that the two smaller ones add up to be the larger one. Let me erase this, and then I'll do the next problem. You can draw a picture for each one, or you can kind of do what I'm doing. All right, the next one, they said that COD is this bigger angle here, that larger angle. It was equal to 8x plus 13. All right, the next angle, BOC is this one next to it, adjacent, BOC. It's equal to 3x minus 10. And then they say BOD, which is this angle from here all the way to there. So it's the two of those together. It's equal to 12x minus 6. Hopefully you're seeing a theme that we're adding two angles to be a bigger angle, right? Either that, or we just show that two angles are equal. In this case, none of those angles are equal, so that means we're going to have to use angle addition. Okay, so the way I did it, angle addition, the measure of COD, 8x plus 13, plus the measure of BOC, 3x minus 10, was equal to the measure of BOD, 12x minus 6. Combining like terms, 8x and 3x is 11x. 13 minus 10 is 3. Again, equal to 12x minus 6. I subtracted 11x from 12x and got 1x. Add 6 to 3 and get 9. So x is 9. Plug that back in for each angle. Measure of COD was 8 times x plus 13, or 8 times 9 plus 13. 72 plus 13 is 85. BOC, 3 times x minus 10. 3 times 9 is 27 minus 10 is 17. And the measure of BOD is 12 times x minus 6. 12 times 9 is 96, minus 6 is 90. So that's how I did that problem. So that was numbers 7 and 8. They used those two pictures, or that picture. Number 9, we don't have a picture, but we can draw our own. On number 9, when we read the problem just says that angle ABC and EBF are a pair of vertical angles. So to draw a pair of vertical angles, I just draw two lines intersecting. And the angles they're talking about are ABC, so I call this one ABC. Now, I don't know if these are going to be acute angles or if it's going to be the obtuse angles. I really don't know. And for the purpose of this picture, it doesn't matter. We can set up the equation and solve it. Actually, I did do it wrong, because if you look, when I say I labeled them wrong, the angles come out to be 128. It should have been those larger angles, not those smaller acute angles. But that didn't matter. I could still solve the problem. It didn't matter where you put the measures. Well, when you're setting up the problem, you don't know if the angle is obtuse or acute, so you just set up a pair of vertical angles. See, anytime we have two intersecting lines, we have two pairs of vertical angles, this pair and then this pair. So for this purpose, it doesn't matter to start with. So we said ABC is 3x plus 8, and EBF, vertical to it, is 2x plus 48. Vertical angles are always going to be congruent. They're going to be equal. So I just set these two equal. 3x plus 8 equals 2x plus 48. Solve it. Subtract 2x and I get x. Subtract 8 from 48, I get 40, so x is 40. Then you just plug it in to find the answers. ABC is 3 times x, or 3 times 40 plus 8. 3 40s is 20 plus 8 is 28. 2 times x, or 2 times 40 plus 48. So that was 80 plus 48 is 128. So they came out to be the same, but like I said, my picture really wasn't correct because it should have been these two angles, right? Instead of those two, the shorter or smaller angles. But it didn't matter. Either way, regardless of where I put those measures, the answer would have came out the same. All right, number 10. It just tells me, and I don't have to draw a picture. You can, but I don't have to. It says that we have two angles that are complementary. Okay, two angles that are complementary. And these angles are not adjacent angles. I know that by looking at their names. See, in the problem it says angle JKL and MNP. Well, they're not adjacent or they'd have the same vertex, right? That's part of being adjacent. They're just two random angles, but they're complementary. Since they're complementary, that means their sum is equal to 90. So what I did, I said that the measure of angle JKL plus the measure of NP is equal to 90. Then I substitute what they told me the measures were. JKL was 2x minus 3. MNP is 5x plus 2. And remember, they equal 90. Combine like terms, 2 and 5 is 7x. Negative 3 and 2 is negative 1. Add 1, 7x is equal to 91. Divide by 7, x is 13. And then again, we find the variable x, but then we got to find the measure of the angles. So we just plug it back in. This time they didn't even ask us for x. That's not really a part of the answer. But we had to have it to get the measure of the angles. So the measure of JKL, remember, was 2 times x minus 3, or 2 times 13 minus 3. That'd be 26 minus 3 is 23. And the measure of MNP, 5 times x, or 5 times 13 plus 2. So that's, 65 plus 2 is 67. So that's number 10. All right, now let's go back to the worksheet real quick because I have some more problems that I was able to answer on the worksheet, like number 11 through 16. Can you make each conclusion from the information in the diagram? Explain. Again, we've got to get used to reading diagrams and seeing what information we know. I'm just looking at this diagram right off just to some observations. I know that angle 4 is congruent to angle 2, right? Because they have the two arcs in them. And I know that angle 3 will equal the measure of 1 and 5 together. Look, they put arcs in those. We know that anyway because those are vertical angles. And vertical angles are congruent, both those pairs, 2 and 4. And angle 3 plus the angle that 1 and 5 add up to be. So then they're asking me some questions. Do we know that 3 and 4 are congruent? No. We do not know that 3 and 4 are congruent. They're adjacent. They are supplementary because they form a linear pair, but not that they're congruent. There's not marks. They're not marked congruent. And I put that they are supplementary, but they're not marked congruent, okay? That's why we know it. Angle 2 and 4, are they congruent? Well, 2 and 4, yes. They have marked them congruent, and they are vertical angles, okay? So they're vertical angles, plus they've marked them congruent with those hash marks, or not hash marks, I don't know what you call those little arcs. Number 13, is the measure of angle 1 plus the measure of angle 5 equal the measure of angle 3? Yes. So notice 1 and 5 added together make this angle, which has 1 arc, and 3 has 1 arc. So yes, 1 plus the measure of angle 1 plus the measure of angle 5 equals an angle vertical to angle 3. Not only is it vertical, but they already had those arcs in there showing that they were congruent. Okay, and then number 14. Is the measure of angle 3 equal to 90? No. They did not mark it. It's not marked as a right angle. Marking as a right angle would have to have a box. They didn't put a box in there, so no, it's not a right angle. Okay. All right, and then 15 and 16 again, I worked some of these on separate sheets of paper. I didn't have room there, so I'll show you what that's going to look like. Okay, here's number 15, and I had to draw my own picture. Okay, they didn't have a picture for us. I had to draw my own picture. It says ray KM bisects an angle called JKL, and JKM is equal to 86. What is JKL? Well, since one of them is 86 and it's being bisected, I knew it was going to be a big angle. So I went ahead and drew an angle JKL. I drew KM, a ray bisecting JKL, and then it said one of the angles, JKM was 86. So if that's a bisector and it bisects, splits it into two congruent parts, so that's 86, and the whole thing will be 86 plus 86. See, the definition of an angle bisector says those are equal. And then we know that JKM plus MKL is equal to JKL, the big angle, that's angle addition. So just substituting in their measures, 86 plus 86, the measure of angle JKL would be 172. 86 and 86 is 172. Number 16, again, we have to kind of draw our own picture. I have a ray SV that bisects an angle RST. So here's my angle RST, SV going down the middle, splitting it into two congruent angles. And then they say that RST is 62. So the whole thing is 62. So guess what RSV will be? Well, both of these angles we know. 62 divided by 2 is 31. The angle bisector splits into two congruent angles. So I said those two angles are congruent by definition of an angle bisector. Added together, they're equal to RSV. So if RSV is 62, then RSV plus RSV, I'm sorry, RST is 62. RSV plus RSV, or two RSVs is 62. So one RSV would be 31. You just do division. It's real easy to see if you put it on the picture. My solution or my explanation, at this point I wouldn't expect you to give that kind of an explanation. Later on, that's what we'll do and you'll understand it better by that time. But that's why I'm going ahead and demonstrating it that way now. All right, number 17 on the next page, we had problems, and again, they didn't have a picture for us. See, they said that we have a ray QS bisects an angle PQR. Solve for X, find the measures. Okay, or might find the measure of PQR, the big angle. So I had to draw an angle with a bisector. So number 17, here's my angle PQR. There's QS bisecting it. It may not be right down the middle. I just sketched this. I didn't measure to make sure it's bisected exactly. But because they said it's a bisector, I know these are congruent. Okay. Now, in number 17, they tell me that the measure of angle PQS with QS down the middle of PQR, PQS is 3x. SQR is 5x minus 20. Set them equal, okay, because the angle bisector. Set them equal, solve for x. I subtracted 5x from 3x and got negative 2x. Negative 2x was equal to negative 20, so x would be equal to 10. Okay, that means if x is 10, then these angles, this one, PQS, would have been 3 times x, or 3 times 10 is 30. SQR would have been 5 times 10 minus 20. 5 times 10 is 50, minus 20 is 30. And together, 30 plus 30 makes the big angle, PQR. That's what they asked for, and it's 60. They never asked us to find x. Yeah, they did. Solve for x. I'm sorry, it did. Solve for x, then find the angle, measure PQR, and it was 60. I did the same thing on the next one. It's the same picture. We have the same angle, PQR, and QS bisects it. PQS, this time, this angle, PQS, will be equal to 2x plus 1. RQS, which is the other angle, is 4x minus 15. Since that was a bisector, these are equal. Set them equal, solve for x. Okay. When I set them equal and solve for x, I got x is equal to 8. Plug that back in for each measure. It's the same thing as number 17. It works the same way. The answer, of course, comes out differently. But when I put 8 back in for x, 2 times x plus 1, 16 plus 1 is 17. 4 times x minus 15. 4 times 8 is 32 minus 15 is 17. And 17 and 17, those angles equal the big angle PQR. So there, it's 34. The big angle is 34. Okay. Now 19 and 20 use really the same picture. Let's see. I think I did that. I have it on another sheet here. I usually do them all on this graph paper, but I had to make copies so that I could scan them. But on number 19, same thing, QS bisecting PQR. They tell me that the measure of PQR, which is the whole angle, PQR, is 3x minus 12. And they tell me that the measure of PQS is 30. So PQS here is 30. Now remember, a bisector, these two are congruent. So if that's 30, this is 30. So that means that 3x minus 12 is equal to 30 plus 30. Or equal to 60, right? Add 12, 72, divide by 3, x is 24. And then when I plug that back into the measure of PQR, which was this 3x minus 12, 3 times x, 24, minus 12, 72 minus 12 is 60. And that makes sense, because 30 and 30, the whole thing had to be 60. To be honest, we didn't have to set up and solve that equation other than they asked me to solve for x. We knew this angle had to be 60 because that was 30 and it was a bisector and that was 30. So I knew the big angle was going to be 60. But they did ask to solve for x and find the measure of the angle. So just take some time and think. You can see that those solutions make perfect sense. Number 20, same picture again. QS bisects PQR. They give us these measures, PQS and the measure of RQ, or SQR, those two. They're equal because the angle bisector, set them equal. Solve for x. X was 9. Plug 9 in for the measure of the angles, or x in the measure of the angles. 2 times 9, 2 times x plus 10. 18 plus 10 is 28. 5 times x, 5 times 9 is 45, minus 17 is 28. And that makes sense. Remember, they have to come out equal because the angle bisector. And so the big angle, PQR, is equal to 56. So that's demonstrating and using the answers and solving those problems. I got those right. All right, now let's go back to the worksheet. 20 through the rest, I believe I was able to solve on the worksheet itself. So number 21, we're supposed to look at this picture. Can you make each conclusion for the information in the diagram below? Can you? Here's the diagram, but can you make this information? Do we know that angle DAB, now notice it says explain, so you've got to give me a reason. Do we know that the measure of angle DAB and DB and CDB are congruent? Well, DAB, that's this angle. CDB is that angle. Yes, we know they're congruent because they are marked congruent. That's how we know it, because they told us that. They marked it. Do we know that ADB up here at the top and CDB again at the top, these two angles, do we know they're complementary? The answer is no. We don't know they're complementary. We would if we knew that ADC were a right angle, but we don't know that. So no, we don't know that the angle ADC is a right angle, so we don't know those are complementary. Okay? They're adjacent, and they could be complementary if ADC was 90, but they didn't show us it's 90, so the answer is no. Do we know that ADB, again the same angle at the top, ADB, this angle, and angle CDB, the same angle at the top, do we know that these are congruent? No. We were not told that this bisected the larger angle ADC. We're not marked congruent. So there was no way we can know those are congruent. No, they are not marked congruent. Now, later on they might have told us, or they could have told us, that DB bisected angle ADC. They didn't tell us that. But if they had told us that, then yes, they would have been congruent. They didn't tell us that. So see, there were ways that we could have known, but the information on that diagram doesn't lead us to those conclusions. Then next, ADB at the top, and BCD, this angle. Do we know that those are congruent? And again, it's no. We don't know they're congruent because they're not marked congruent, so there's no way we can determine that. Okay. All right, then number 25, we have two angles. They say two angles are complementary. They're complementary, their sum is equal to 90, right? So I put over here, if these two angles are complementary, this angle plus this angle is equal to 90. Then I substituted in the measures. The measure of MLN was 7x minus 1. The measure of JLK is 4x plus 3. So those two added together is equal to 90. 7x, 4x is 11x. Negative 1 and 3 is positive 2. Subtract 2 from 90, 88. 11x is equal to 88. X is equal to 8. Then over here, to find the measure of those angles, I plugged in x in each one. The measure of angle MLN was 7x minus 1. So 7 times 8, 56 minus 1 was 55. And then for the measure of angle JLK, 4x plus 3, or 4 times 8, 32, plus 3 is 35. And 55 and 35 add to be 90. So they are complementary. It worked out. It did what I wanted it to. It said solve for x. X is equal to 8. Find these measures, 55 and 35, and then show how you can check your answer. 55, I guess I should have written that down. 55 plus 35 equals 90. I always tell people to check their answers, and that's all they're asking you that question too. Reasoning. The next problem says describe all the situations in which the following are true. Two vertical angles are also complementary. Because vertical angles are congruent, to be complementary, they both have to be 45. 45 plus 45 is 90, making it complementary. And those angles could also be vertical because vertical angles are congruent. Next, a linear pair is also supplementary. all linear pairs are supplementary. All linear pairs are supplementary. So that would be pretty easy to describe. If it's a linear pair, together they add up to be a straight angle. Two supplementary angles are also a linear pair. Two supplementary angles are also a linear pair. They would have to be adjacent angles. If they're supplementary and a linear pair, they'd have to be adjacent and they'd have to be right angles. I should have wrote that too. They have to be adjacent right angles. In order to be supplementary and a linear pair, they'd have to be adjacent right angles. And next one, two vertical angles are also a linear pair. Well, actually, vertical angles can't be a linear pair because vertical angles, but they're telling me to describe all the situations in which the following statements are true. So vertical angles cannot be a linear pair because vertical angles, their sides are opposite rays of one another. A linear pair have a common side, so that wouldn't work. But if these are right angles, if I have two lines that intersect and form these four right angles, then these vertical angles are a linear pair with other right angles. So all four angles are right angles. That's the only situation I could think of if they are all right angles. But really, vertical angles, by definition, they're angles whose sides are opposite rays of one another. They can't form a linear pair because a linear pair are adjacent angles, and vertical angles are not adjacent. They don't have a common side. So that really, there's no situation where that exists. And it's just when they're right angles, then they can be vertical and a linear pair, and they can all be congruent. But still, that's not. I don't think their question was very well stated. And then number 27, I couldn't remember if we had to do 27 in the homework. It said open-ended, so you just had to create your own. Write and solve an equation using an angle bisector to find the measure of an angle. So I just put in here that this ray, we'll call it BD, bisected angle ABC, but I didn't write an equation. I should have written an equation to do this, but these two angles add up to be this one. It's open-ended. I'll give us an example in class, or any example where this angle plus this angle equals the whole angle, like we had up there previously in some of the other problems. Like 17 through 20 would have been the same situations, but you could have made up your own problem there. So even if I gave you an answer, it wouldn't be the answer that you have because it's an open-ended question. Okay.